Good morning. Today what we're looking at is we're starting to draw or look at drawing the graphs of sine and cos theta. So what I've got behind me is I've got a pretty basic axis set up, and I've got it marked in radians, and I've got it marked in pi on 2 increments. So if we are talking about the graph of y equals sine of x, when x is 0, what does the graph equal? When x equals 0, yeah. So when x equals 0, then what's the sine of 0? Well, it's 0, so we'll make a mark there. What is y when sine, so when x equals pi on 2, what's sine of pi on 2? Think back to your exact values table from yesterday, or from last lesson. So sine of pi on 2. Remember, you run right through the 0, pi on 6, pi on 4, pi on 3. Yeah. And pi on 2 is exactly 1. What about sine of pi? Yeah. So it's back to 0. Now we move past, and we move past pi into the third quadrant. So this is between pi and 3 pi on 2. What is sine of 3 pi on 2 going to be based on our exact values table and symmetry properties? It's going to be all the way down to -1. And then sine of 2 pi, we come all the way back around, and we get back to the start, which is at 2 pi is 0. So now, to very, very carefully sketch that out. Now, to help me sketch this out, we know that there is a exact value of x that results in it being a half. Which one is it? To help me plot my graph, what value of x results in y equal a half? Pi on 6. Anyone else want to have a guess? Or anyone else want to see if is that correct? Don't just rely on that person. Yeah, because it is pi on 6. So, pi on 6, if this is pi on 2, then we want to go about a third of the way there. So, here is approximately going to be pi on 6. And that means, where else is it going to be pi on 6? It's going to be pi on 6 back from here. And then we can plot the point pi on 6 from here, and then pi on 6 back from 2 pi. But of course, we'd be in the negatives. And then I can join my dots together. Wow, that actually went really smoothly. I was expecting you have to do that like 3 or 4 times. All right. And our graph looks like this. And if I was to extend it beyond 2 pi, I would just keep getting copies and copies and copies of this exact pattern. All right. So this is what's also sometimes called a sine wave or a sinusoidal wave in physics. But for our purposes, it is just called a sine wave. Now, the time it takes for a circular functions graph to completely repeat itself and go back to the start so that it starts the whole loop again. So the time or the distance between here and here is called the period of the graph. The distance the graph goes from the center line to either its maximum or its minimum. So in this case here, my center line, everything bounces around here. This distance here is called the amplitude. And all I'm doing there is measuring the straight line distance between the top and the bottom. So in this case here, this graph would have an amplitude of 1, regardless of if we're talking about negatives or positives. It is just the absolute distance between a peak or a bottom of the graph to the center line. Because like most graphs, you can move these around, and you would move the center line around. So the amplitude is in reference to where is the center line of that graph. Now, of course, because this is a standard one, the center line is just on 0. So the period of a standard sine graph is 2 pi. All right, because we've got what's the coefficient of this x in here? What is the coefficient of the x inside my sine function? Yeah, it's 1. So we can take this graph and we can start sticking in some extra values to describe how the graph will change shape. Y equals a sine n x. So A is your amplitude. And n goes into a formula of 2 pi on n, and that gets you the period of your graph. So that will tell you how long it takes for a graph to repeat itself. So in this case here, because I haven't done anything to it, except just then I accidentally did, this graph here, amplitude A is 1, because there's nothing at the front. So the amplitude is 1, and then the period n is 1. So 2 pi on n tells me how long it will take for the graph to repeat itself. So if I take my sine graph, I'm just going to move it out of the way for a little bit. We don't need it right now. So we don't need those. let's talk about our good friend cos. Why? 'Cause I said so. Also means I don't have to redraw this. So, thinking back to our exact values table, y equals cos of x. What is cos of 0? Cos of 0 is 1. Alright, remember, it is basically, if you go through the exact values table, cos is starts at the other end and works backwards. So in this case here, cos of 0 starts all the way up at 1. What does that mean for cos of 2 pi? What does that mean for cos of 2 pi? It's not 0. It's also going to be 1. What about cos of pi? Yeah. So we've got there, and there. So, what is cos of pi on 2? Yeah, it's 0. And then by that logic, cos of 3 pi on 2 is also going to be 0. So, if I connect the dots, what's it going to look like? Actually, let me just grab my friend over here. Oh. The wave pattern still fits. But that's sine of x. Obviously it doesn't fit perfectly, does it? Does it fit perfectly? Does it fit perfectly? Yep. Oh, what about this dangly bit over here? Alright, I just have to move it over. Look, if we were only being asked to draw, then I guess we could get away with it, but here... Alright, to help me out, because I've got this half here, where's the half going to be on a sine of cos graph? Sorry, a function cos x graph. What value of cos of x means that y equals a half? Again, go back to your exact values table so that we can help, so it's pi on 3. Now, the one good thing about pi on 3 is that we know that it's pi on 6 from pi on 2. So that means I can basically already put a mark there for myself here and here. And then I can also put the negative ones here and here. So what's pi on 6 to the left of 3 pi on 2? Well, if this is 3 pi on 6, and I'm going pi on 6 back, then I'm at 2 pi on 6, which is pi on 3. And then this one here is going to be 2 pi on 3. So it's going to be pi on 6 more. I'll get rid of those so I don't confuse myself. And I will now connect the dots like that. A little bit wonky, but you know, with practice. With a bit of practice, here we go. Cos of x. It's the same shape as sine of x, except it starts at the top and ends at the top. The rules for it are exactly the same. A is the amplitude, and n goes into this formula here, and that tells you the period. Again, how long it takes for the graph to repeat itself. The thing I want you to think about before I send yous off is, what does n and a do to the graphs? How do the graphs change because of what you're doing to them? All right. So A is stretching vertically. Yep, I'm like that. Yep. If I wanted to make my graph thinner, if I wanted to squash it horizontally, what should I do to my value of n? I'd want to increase it. Because if n is more than 1, then that means the period formula is going to be 2 pi on a larger number, which cancels down, which means the graph would then suddenly repeat in a much quicker period. So if I changed 2 pi, so I said n was 2, then how quickly would my graph repeat itself? So if I said n was 2, what would the period of this new graph be? Yeah, it would just be pi. So we can visualize that. Y equals cos of 2x. A is the same, but n is 2 pi on 2, which means here it is pi, which means that I would take this entire graph and I would squash it. Can I do that with this, actually? Only lets me shrink and grow. Dang, I was going to get all cute and like just literally squash it. I'll just have to redraw it. So we take our points that we know. Now we know that the graph is going to end at pi. So we've halved that, which means we're probably going to have to squash this. And this would now be down here. And we've squashed the graph. So in blue is cos of x, and in black is our cos of 2x. So let's put that away for a second, and then I'm going to show you a quick way to visualize these on your CAS, because I find that having your CAS do things is quite helpful. So we'll go to graph and table, clear all these. So what we're going to do is we're going to go A times sine bracket n times x. Now the reason why we do that is so that when we press the variables button, it doesn't completely muck us up. So when we do that like this, it turns into this, and I now have a wave on my calculator. Now my calculator is set to radians, so it makes it very easy to draw in such a small scale. Now what I'm going to do is I'm going to change my window a little bit. What I want to do is I want to draw 0 from 0 to, and I can manually do this. I'm going to draw until 6 pi. So if you use the keyboard, you can put pi in yourself. I'm also then going to change the scale to pi on 12. I'm going to change my y minimum and y maximum. The y minimum is going to be, we'll go -5, and my max is going to be 5. So each single one of these little marks from left to right are going to be pi on 12. As I fiddle with my A value, what happens? All right, the graph starts to stretch like we said it would. What happens if A becomes negative? Anyone want to have a prediction? It flips. Well, first of all, 0 means nothing happens. And -1, it just turns the graph completely upside down. But notice how those intercepts never change. That's all fixed. Now if I start playing with n, so what happens if if you were watching just then, what happened when n became negative? What happened when n became negative as well? It flipped it as well. Interesting. Now, to really see what you want to really see what I want you to see, we need to go into settings. We need to move over to slider 2, and we are going to change the step to 0.25. Because that's the only way you will be able to see what I want you to see. So here, make this slightly easier for you. I'm going to change the scale to pi on 2, just to make it a little easier for you. So, the whole thing repeats in 2 pi currently. If I make it a half, how long does it take to complete a full circle now? It's going to take 4 pi. If I go even smaller, how long will it suddenly take to complete a full circle? I go from 0 all the way up, all the way down to 4 pi. That would mean that, yes, correct, Hamid, I would have to then go another 4 pi before I get back to normal. Alright? Cos works exactly the same way. I can replace those around and it does everything the same. Funnily enough, if n is -1 and a is -1, it goes back to just being a negative graph again. All right.